Dynamic memory is a memory which is made available and made unavailable as required when the program is running. I must mention static memory allocation when introducing dynamic memory or dynamic memory allocation. Memory allocation that takes place at compile time is static memory allocation. Compiler knows how much memory space to allocate and what type of data that memory is going to be used for. Memory space for regular variables such as integer with name age, double type with name price, character type with name grade, the array with size specified, an object of some custom type. We want to have a custom type here. Component 1, and also a pointer variable. All these are statically allocated, which means compiler does determine the memory space required for these variables. In contrast, dynamic memory allocation takes place during runtime when program is running. Let me describe the syntax for allocating memory space for dynamic memory allocation. We have two keywords, new and delete. These are the keywords that are involved in dynamic memory allocation. New keyword is for allocation. It will allocate dynamic memory and it will return the address of that memory, which is typically stored in a pointer, and I'll show you how to do that in a moment. To allocate the memory, you can use a new keyword followed by the type of the data you want to store in the memory. If I want to store integer type int, this will allocate this will create a 4-byte space in the dynamic memory space, and it will return the address, and you can store that address in ptr, any pointer, I mean integer type pointer. Let me call this give different name, my ptr. This will allocate, and when you allocate, you can also set data into it. If you want to set 32 value, you can do like this. And my ptr is the thing that you can use to access the dynamic memory space. If you simply write expression like this, it will allocate dynamic memory, but it will return the address, but that address you don't record the address. That means you cannot access that memory. So you need to be able to access that memory so that you can release that afterwards. Otherwise, this kind of syntax will lead to something called memory leak that is not desired. Now, if I want to access the data, I could use dereferencing like in the pointer, because we have a pointer to point to that dynamic memory space. And if I want to set data to it, we have you can set new data to it, and you can again access it afterwards. Right. Now let me show you the output of this program. We are in the terminal. In the terminal, I have that file in main.cpp, that code. I'm going to be compiling this using this compiler. So output file main.exe and source file main.cpp. it has compiled. Well, there is only warning because many of the variables where I have used in the code are not used, so this is the warning for that. I will just ignore this. I will execute the file. It will. So you can see 32, 63 are being displayed here. 32 was the data that was initially set to the dynamic memory space, and 63 was set into it afterwards using dereferencing of the pointer. Now let me demonstrate how to use delete keyword to release the memory. This is pretty straightforward, very simple. You type delete keyword followed by the name of the pointer that is actually pointing to that dynamic memory space. So this will solve the purpose, right? If you don't release the memory, that will result in the memory leak issue, so you must delete each dynamic memory you have allocated. You need to release it properly. Now how to create a dynamic array. We can make use of the same pointer to point to the dynamic array. In this case, it was only one element in the dynamic memory space. But if you want to store multiple elements in the form of the array, then this is the syntax. New keyword followed by the type of the data you want to store in the array, or the type of the elements of the array, int in this case, and you have a square bracket and the size of the array. Suppose if you want to store 6 elements, then this will actually allocate a memory space to store 6 integer elements and return the address. And you need to again store that address in a pointer. I can reuse the previously used pointer because this myPTR is not pointing to any place. Therefore, I can reuse it. But if you want to reuse when it is still pointing, there is no delete, then you have to make sure that you release the memory. Otherwise, it will result into a memory leak issue. Now we have this myPTR pointer pointing to a dynamic memory space. You can copy the data. You can initialize the data into this space directly. 3, 4, 7, 8, 1, 9. So it will create a memory space and set data to it, 3, 4, 7, 8, 1, 9. And if you want to print this data, you can use a loop. There are 6 elements. And the syntax for accessing through the pointer is through dereferencing. But if you want to access the element, then you need to have something that will increment, the pointer. This will actually display the data, content of the pointer, content of the array. Now if you want to make change, then again you can use the same expression and set data to it. For example, if I want to add 10 to each element, all the elements 10, and we can see the data again. So this should display this will actually display the previously stored data in the dynamic array, and also it will display the modified version of the data. Let me show you the output in the terminal. Compile and execute. Now we can see 3 and 10 plus 6 13. 4, 10 plus 4, 4 plus 10, 14, 7, 17, 8, 18, right? So these two things are actually displayed in one iteration of the loop in the code. So the first data was displayed by this cout statement, and second data was displayed by this second cout statement. Now finally I will talk how to actually release this memory. Releasing a dynamic array. The syntax is pretty similar to this releasing the one variable, one dynamic one value in the dynamic memory space. Only the difference is that you need to put this bracket here. So this will solve the purpose of deleting the array. You have to make sure that you use a proper syntax. If you have only one variable, one value, you use the syntax to release. If you have an array, then you use this syntax to release. Now again, you can reuse. You cannot use this pointer to point to a dynamic array holding a different type. For example, if I do something like this, this will be a syntactic error. So compiler will not allow. If you want to do this, you need to create a new pointer of double type, and then you can copy it. Let me do the compilation and see the output, what happens here. Now we have an error, right? So since this is a integer pointer, so we cannot use integer pointer to point to a double array. We need to make sure that the correct type pointer is pointing to our dynamic array. So let me comment this out and try to compile again. It's compiling, there is no error, so I can run it. So it is displaying the output. But we have not used the dynamic double type array, so but it's not showing error. That means it is accepting. And one final note: if you forget to release the memory, then that results in an issue, a problem called memory leak. And if this memory leak actually piles up for different objects, different variables, then amount of memory that is occupied but never used can grow, and that can ultimately sometimes slow down your program execution, because a chunk of memory could be unnecessarily occupied. So this is the end of my recording. Thank you for watching.